Hey everybody, we're going to be talking about how to use this instrument right here, which is an XRD, which stands for X-ray Diffractometer. This instrument is mainly used to look at crystalline solids, and what it actually does is measure the distances between planes of atoms within crystalline solids. So we're going to talk about how to boot it up, how to run the software, how to get the data out of it, and then make sure that we're shutting it down properly. So first, to boot it up, you can kind of hear maybe in the background, we have down here a water chiller, and this helps keep the X-ray tube in the instrument nice and cool. Often it will always be on. However, if it is not on, then the first thing that you should do to boot it up is to reach down here and hit the toggle switch on the very front to turn it on. Then next we can work on this instrument. So here's the instrument itself. It's a Rigaku MiniFlex 2. And once the water chiller is on, then we can just power it on right here. And then you'll start to notice that there are some lights that already switch on. So one of them will be a big light up here and then a few lights down here on the control panel. This is not fully booted up yet. The next thing that we have to do is just press this button right here that says X-rays, and then on to turn the X-rays on. And again, you'll notice that now the X-ray light is on and the fourth and final light here on the control panel is on. Now everything from the system point of view is up and running and ready to go. And then the last thing that we just have to do is just turn on the computer if the computer is off. The only thing really weird about that is when you boot it up, it will ask for a password, and the password is on the top of the tower. To prep the sample, we're going to be using this glass slide right here. This has a front and a back side. The front side is completely flat, just glass, but the back side actually has an indentation there in the center. We call this indentation in the center of the window, and it really just depends on the type of sample that we're going to load. So if you have really big crystals, or if you have a lot of sample, then we're going to be using the side that has that indentation, and you're gonna pack that indentation until it's flat with the top. But if you have a small amount of sample or your crystals are really, really small, we're going to use the back side where it's flat. But the nice thing is that this window will help tell us where we want our sample to be on the slide. And then there's different types of samples that you might want to put on the slide. Some of them, our crystals are grown wet, and some then our crystals are dry. If our crystals are wet, you can deposit the crystals directly on the slide, and the little bit of solvent that's left over on the slide will help adhere the crystals to the slide. But today we're going to be using salt, which is a nice dry crystal, and so we want to have something to adhere to it. So we're going to be using some vacuum grease. This is a silicone grease. And to use this, all you're gonna do is just squeeze out the smallest amount out of the tube and then just rub it very lightly on the front of that window. And then we can grab just a little bit of our salt and we'll just pour some right there. And then the type of coverage, we just kind of want uniform coverage around that window area. It doesn't have to be fully filled, but obviously the more sample we can get on the area, the better signal that we're going to get. Now that our sample is on the slide, now we're just going to put it into the XRD itself. There are X-rays on in the instrument, and those X-rays can be very harmful to you. And right now, both of these lights are on, meaning the X-rays are on, and there's a shutter that's open. And when we open up this door to put our sample in, what we're going to want to make sure to do is make sure that this light turns off, meaning that the shutter is closed, and then it's safe for our hand to go into the instrument. So we're going to turn this lock to open. The light turns off, which means that then we can open up the door and we can put the sample in. When we put the sample in, we're going to put the sample face up on the window, and then it goes into the instrument above the two tongues that are sitting inside of this window. And then we can close the door and lock it and see that the shutter opens again. Now our sample's ready to be analyzed. Okay, once the sample's in the instrument, then we just have to program the software in a good way to make sure that we're getting all the information that we want. So on the main desktop of the computer, the program that we're going to want to use is this yellow button right here that says standard measurement. When you press on that button, it's going to just bring this window right here. And this is our main window to do all the things that we need to do with the software. We're gonna work right in through here and just talk about each different part. So for some reason, the software has a use column. You can actually click no and then the instrument won't work. So make sure that this says yes, because then it's actually going to tell the instrument to do stuff. We don't have a printer connected to this, so that's always going to default at no. And then we're going to make sure that we're just going to put our file wherever we need it. And so to do that, you're just going to browse, and then it'll pull up a reference for putting your file, and that can go wherever you need it to go, either on the desktop or in some subfolder. You can put in a sample name. The sample name doesn't really mean anything. It does go just into the base file. Oftentimes we'll leave it blank. But the most important column is this one right here, which is the condition. And so in the condition, this tells the instrument what degree angles it's going to analyze of your crystalline solid. It's also going to tell how fast it should go and what type of information that you're going to need. So we'll double click on this one, and that'll bring up a new window. And this window tells us all the information that the instrument needs. So in this case, since we're doing salt, I have already pre-programmed a rock salt for sodium chloride in here. And then with this, it's going to ask what is the starting and stop angle. These are our 2 theta angles that we'll talk more about in class. And so for rock salt, a good starting angle is going to be 25 degrees. And then a good stop angle is going to be 60 degrees. In general, this instrument can go between 3 degrees and 70 degrees. The longer that you have to analyze, the longer it's going to take. However, the more information we're going to get. So we're always going to be playing between these angles to get more or less information and take more or less time. This next column right here is the sample width. This tells it how often to take data. So in this case, it's telling us to take data at every 0.02 degrees or angle degrees. And then this last one is our scan speed. This is how fast it's going to go between angles. So right now it's set at 4 degrees per minute. And so you can speed things up by increasing this speed or by shortening the different degree angles that we're going to go through. However, we don't typically go much faster than 4 degrees per minute, because beyond that, then we're going to lose resolution of our analysis. These last 2 are telling how much power we're going to give to the laser. These 2 you should never touch. They should stay at 30 kilovolts and 15 milliamps. Once you have all of those in there, it automatically gets set to a certain preset. In this case, we're in preset number 7. And so if we exit out of here, it automatically saves, and then we can put whatever preset we want in here. I already have preset number 7 in there, but I always like to check before running the sample that that preset is going to do what we want to do. So I'll just double click on this again and make sure that indeed, yeah, it's the program that we want. So then to run the analysis, you're going to click this yellow button right there at the top left, and that tells the instrument to go. It will take about anywhere between 10 and 30 minutes to run a single sample, depending on your speed and how many angles you're wanting to analyze. So I have already run a measurement for our rock salt. And this is what a typical XRD spectra will look like. On the x-axis, we have 2 theta degrees, and that's our angle degrees. And then on the y-axis, we just have intensity. And so what you'll typically see with a really crystalline sample is a really flat baseline there at the bottom with peaks coming up at different points. So we have a really small peak down here. Our largest peak is coming in at about 32. And then we have a couple of other peaks that are further on in degrees. The last thing that we need to talk about is how to take this data off of this computer into something that's usable, because as it creates this data, it saves it in what's called a raw file format, or a .raw. And there's almost no programs that actually read raw data files. So what we have to do is we have to take the data file, and I just have mine sitting here on the desktop, and we right click on the file, and then we go down to open with. And the second option here is this option that says XRD Pattern Processing and Identification. This program will read raw files and then we can export it into a file format that works a lot better for us. So if we click that, it opens up this program called Jade. And then in here, we select File, and then under Save, we want the primary pattern as a .txt file. And if we save it as a .txt file, then we can open it up in things like Excel or other spreadsheet type software. And then it'll ask us where to save it, and then we can save as a TXT. All right, after we've run the sample, we just have to clean everything up and shut everything down. So the first thing, we're just going to take our sample back out of the instrument. Now remember, the shutter is currently open, so the X-rays are hitting the sample. We just want to make sure that when we open the locking mechanism that this light turns off again. Then we can open the door and then just quickly take the sample out. When we close it, the shutter will open again. For the sample, we're just going to clean it depending on if we want to keep the sample or not. There's different things that you can do with your crystals, but for now, with salt, we don't care to keep it, so we're just going to clean it up with a nice CHEM wipe or something that's very clean. And then this stage is ready to go again for the next one. For the XRD to turn off, we just want to reverse the process that we've been doing. So the first thing I'm gonna do is turn the X-rays off, then that light comes down, and then we can power this down. Really importantly, the X-ray tube in the instrument is still really hot. And if we turn the water chiller off immediately, then we'll melt the X-ray tube. So the water chiller that stays below just needs to make sure that we have that on for an additional half hour after we've turned the X-rays off. And then we can turn it off. It also doesn't take too much power, so often we'll just leave the water chiller on just to make sure that our X-ray tube always stays safe. From there, you can just log out of the computer, or you can take a thumb drive and export your data out to your computer. This computer can stay on as long as you want it to as well.